Hi folks, we've got another asteroid to talk about today. Asteroid 2003 QQ47, or as New Thor likes to call it in his new video about it, Quit Crying 47. He asked the question, will supersized asteroid QQ47 kill us this week? And in his video he basically concludes, no, probably not. 99.9% sure. Well, I'm a lot more sure than that, and he basically says I must be God to be that sure. How can I possibly know whether it's really going to hit us or not? Well, we're going to take a look at that in a minute. He also says that Phil Plait basically invented this conspiracy out of thin air, that there's not really much discussion on the internet about this, and he doesn't really know how he came up with this, claiming that people are talking about it and worried about it and all that. Well, let's see here. We've got all kinds of forum posts and videos talking about this thing. Asteroid around 2/3 of a mile wide could hit Earth on March 21st. Asteroid could hit Earth on March 21st. Asteroid to hit Earth on March 21st. You seeing a pattern here? Another one video, asteroid threatens Earth in 2014, and they are indeed talking about 2003 QQ47 and quoting an article that is 11 years old at this point, saying that it's a threat to hit Earth. Another video talks about it, asteroid 2003 QQ47 may impact Earth March 21st. So yeah, there's a lot of discussion on the internet about this that I've seen anyway. And I saw this being talked about well before Thor's video. I just kind of brushed it aside. I mean, it's kind of silly because they're talking about an article that's 11 years old. I mean, I thought people would get that. It's kind of obvious. But maybe to some people it's not so obvious. I mean, if you aren't familiar with how asteroid orbit determination works, I guess maybe you might still be concerned about this, because what does it matter that it was 11 years ago? It's still a threat to hit, right? Well, the reason why it was a threat to hit, or an apparent threat to hit, is because we didn't have any observations of it shortly after we discovered it. And New Thor asked this as well. I mean, how can they be so wrong? After all, they were talking about maybe hitting on March 21st. Well, the closest approach date, turns out, isn't actually until the 26th. That's almost a full week off. How can they be so wrong? Well, let's take a look here. What I have here is a determination of the orbit using amateur data alone. No professional data. All professional data has been excluded from the orbit calculation. So, just like professionals, amateurs too observe the sky at night and measure the positions of asteroids and comets in the sky, and from that data we can determine the orbit. And we can determine that orbit using just amateur data. So that's what I've done here. And you can see here are the orbital elements I've calculated from the amateur data. And you can see how well the professional data fits the amateur data. The residuals here in the parentheses are quite low. And indeed, it predicts a close approach on March 26th at 12:36 Universal Time at a distance of 0.12832 astronomical units. JPL has the professional solution here, and it predicts close approach on March 26, 12:36 Universal Time, at a distance of 0.128317. That rounds up to 32 astronomical units. Exact same prediction. One here is from amateur data alone, and this is from all the data, primarily professional data. And they are in perfect agreement with each other. So how can we know for sure that it isn't really a threat to impact? I mean, after all, there's got to be some uncertainty in this number, right? Well, let's just find out how much uncertainty in just the amateur data, without even looking at professional data. So here's all the amateur data that we have on this asteroid so far. And when we use that to solve for the orbit and generate a Monte Carlo series of solutions of the orbit, we can find out what the uncertainty region looks like and how large or small it is. Now, we're starting here at midnight on March 21st, the start of March 21st, and we're just going to play forward here, and you can see the uncertainty region's right here. Let me pause it. The uncertainty region is this tiny little spot right here. It's a tiny little blue line of dots of all the Monte Carlo solutions. They're all grouped together in a very, very tight portion of space. That means we have a very good determination of the orbit with just the amateur data, a very certain determination. And as you can see, that uncertainty region up here is nowhere near Earth. And March 26th comes and goes, and Earth starts getting farther away from the asteroid. The asteroid's somewhere in this uncertainty region, and it's not a very large region at all, as I said. It's very, very tiny. So how can we have thought that it might hit us on March 21st. It's nowhere near us on March 21st. It's way up here, right? Well, when we first discovered the asteroid, we didn't have all that astrometric data to work with. For a time, we only had a few observations. And until about September, we didn't know whether it was going to hit us or not. So this data is the amateur data, the series of Monte Carlo solutions of from the amateur data of just the data we had until September, but not including anything from September or beyond. So this asteroid at that time could not be predicted for certain whether or not it would hit Earth on March 21st. We didn't even know when the date of close approach would be. You can see this is what the uncertainty region looks like using just that amateur data, excluding anything from September or beyond in 2003, September 2003 and beyond. So almost all of it excluded, just a few observations that we just had initially. And with only that to go on, we didn't know where it would be in its orbit on March 21st. We have a good idea of what the orbit looks like in general, but we didn't know where exactly it would be in that orbit. We knew it was most likely going to be on the side of the Sun where Earth was, but that's about it. And if you zoom in on Earth, here's the big difference, and here's the reason why it reached a 1 on the Torino scale. If you play forward here, Earth goes right through the uncertainty region. You can see the position of the asteroid could be anywhere in this uncertainty region, and each of these dots represents a possible position of the asteroid. And what happens is, as Earth's jogging along in its orbit, it travels right through the region where these solutions of the asteroid's orbit are located. Now what this says is, okay, Earth is between blue dots here. It's between a bunch of blue dots. So it's right in the middle of the uncertainty region. And what that says is if I continued solving, producing Monte Carlo solutions of the orbit, if I did that a whole bunch more times, eventually I would fill in this area and start getting possible impacts on Earth. In fact, the odds were such that for about every 900,000 solutions of the asteroid, one will hit Earth. That's a lot of solutions. The odds of impact are not very good on that, about 1 in 900,000. So chances are it's going to be somewhere else in the uncertainty region because it is such a large region of space. And that's why we didn't know exactly when close approach would be. That's why we didn't know whether or not it was going to hit Earth. So using just that initial data, we couldn't rule that out. But now that we have much more data covering a lot more time, that's critical. Time is critical. The longer the span of time you've been observing the object, the much tighter your determination of the orbit. That solution you saw a moment ago had, I think, about 11 observations in the orbital solution, about 11 astrometric readings. That's not a whole lot, but this isn't really all that much more. It's about 50 or so, 51 I think. And that's just the amateur solutions. Let's see here, how many did I have exactly in this one? 51 observations, so that is the sum total of amateur observations spanning from August 2003 to April 2005. But because it spans that length of time, a couple of years, the determination is much more certain. You've now monitored the position of the asteroid over a much longer period of time, and even though you don't have a huge number of observations to go on, the observations that were made are very good. They have a very low residual, very low error, tiny fraction of an arcsecond, about 0.3. That's very tight determination. So the observations are very good, and because of that we have a very certain determination of the orbit. But time is critical. You have to observe it over time. That's why we have to find these objects before they're a threat to hit, hopefully years before they're a threat to hit, because it takes time to determine which ones are truly dangerous and which ones are not. It's not something that you find out the night you discover it unless the impact is immediate in the future. When the potential impact is a decade down the line, you don't know exactly where the asteroid's going to be at that point in time, and you can't determine for sure whether or not an impact's going to happen, even if it really is or even if it really isn't. So it's not like the movie Deep Impact where something is found and immediately they know that, a year or two from now, oh my god, there's going to be an impact on just, two astronomers' observations on the very first night. That's not something you're going to determine right away. That's something you need more time to determine. And so as a result of that, you can't hide the truth here. Amateurs are observing these things over years of time, just like the professionals. And so even if the professionals were lying and trying to cover this up, even in that extreme circumstance, you could still determine the truth just by looking at what the amateurs are seeing. The amateurs are looking at this asteroid too. They know it's there. And using their data, you can determine the orbit just as well as you can with professional data. And doing that, we can determine that indeed this asteroid is not a threat to impact. It's not even coming all that close to us. Its distance is going to be 0.128 astronomical units on March 26th. So that's that. Hope you have a nice day.